Hello, you're welcome to our today's class, and before we continue, I want us to take affirmation together. I'm not afraid of mathematics. I know mathematics. Okay? Beautiful. So, we are continuing from our last class. Remember, in our last class, we started looking at laws of indices. We have looked at law number 1 and law number 2. Today, we're looking at law number 3 and law number 4. Law number 3 is when you have this A index M, close the bracket, index N. Now, this law is called multiplying of powers law. Okay, so what I'm going to do, I'll take A, M, multiply by N. This one is different from the product law, whereby we only added the indices. We did not multiply the indices. Because of this bracket, so we are multiplying the indexes. So what it means is that it means AM in number of times. Okay? So, that is to say, if I have, for example, I have 2 raised to the power of 3, close the bracket, index 2. It means I'm multiplying 2 raised to the power of 3 in 2 times. Okay, remember we've done square. It means I'm multiplying it in 2 times. Or I will simply say 2 raised to the power of 3 times 2, which will give me 2 raised to the power of 6. And if I expand this forward or simplify this forward, I'm going to get 2 times 2 times 2 times 2 in 6 places. That will give me 64. Okay? Or I can simply say 2 raised to the power of 3 in 2 places times 2 raised to the power of 3. You see, because it is square. It means 2 raised to the power of 3 in 2 places. 2 raised to the power of 3 times 2 raised to the power of 3. This is 2. I'll take down this multiplication, so I will add the indexes. Add this and this, which is 2 power 6. That will also give us 64. So you see, it's the same thing. So any which way you want to do it is acceptable in mathematics. Then, law number 4, we call this zero index. The law says when you have any number raised to the power of 0, or anything, alphabet, number raised to the power of 0, it is 1. Just 1. It is 1. So I have 1. Now, what this means is that if, for example, I have A raised to the power of N minus N. Remember, A raised to the power of 0 can also mean this. Because if you subtract these 2, N minus N is 0. Any number subtracting by itself, it will give us 0. If I change this to put a number, let's say 2 minus 2, it's 0. To give me A, 0. Now, if we remember the law number 2, law number 2 tells us that if we have A N divided by A raised to the power of N divided by A raised to the power of N, the same. I will take one of them, I will say N minus N. Because of this division sign, I will subtract. So it's the same thing with this. Okay? But now, let me write this like this. A N divided by A N, which is the quotient rule. Look at it. If we divide anything by itself, it's going to give us 1. Okay? So this divided by this, so we are going to have 1. Remember, any number divided against itself is 1. Okay? Like 3, use 3 to divide 3, that is 1. So that's what I just did here. So what it means is that A raised to the power of naught is equal to 1. Not just A raised to the power of naught. Any number raised to the power of 0 is 1. Okay? So this is just the proof how it can give 1 when you work it out. Just know that any number raised to the power of 0 is 1. No matter how large the number is, even if it's 1 million, 1, 0, 0, 0, 0, 0, 0, raised to the power of 0 is 1. Okay? So I want to thank you for today's class and your active participation. Well done. and a good one for you, because you know mathematics and you're not afraid of mathematics. So see you in our next class. Bye.